This is our third video about measurements of shapes, and this video is on the topic of volume. In the previous two videos, we talked about perimeter, another thing we can measure about a shape, and we said perimeter was the distance around the outside of a shape. We also talked about area, and what was area? Area was not the distance around the outside of a shape, area was the space on the inside of a shape. Now, I'm going to mention something here that I did not mention with the area video. Area is the amount of space on a flat surface. And that helps us to see what's going to be different now when we talk about volume. So, where do we hear the word volume? We talk about the volume of air in a room, the volume of water in a bottle, the volume of... Volume always refers to the amount of... I'm not going to use the word space. We use that for area. I'm not going to use the word distance. We use that for perimeter. Volume is the amount of, I could say really informally, the amount of room on the inside of something, or the amount of capacity, there's a more technical term, on the inside of something. I can think of it as the amount of water that I can put inside a container. So volume is very different than perimeter. It's not the distance around the outside of something. It's also very different than area. Area only refers to space on a flat shape, like a square or rectangle. Squares or rectangles can't hold any water. It just runs off because it doesn't have any sides. Volume is when the shape that we're talking about is not two-dimensional, like it was with area. It's now 3D. This shape has got a left and a right. It's got a width. It's got a front and a back. It's got a width. It's got a length. And it's also got a third dimension. That's what 3D stands for, 3 dimensions. It's also got a height. So the container I drew here was a circular cylinder, but it might be even clearer to see if I drew a rectangular container like this. This has a width, it has a length, and it has a height. And because of that, there's all of this room inside that can be filled up with something. That's the idea of volume. How much room is there inside something so I can fill it up with water, with air, with Cheerios, with coffee, whatever you'd like to fill it up with. So, volume. Now, some of the units of volume. So we said that when we measured perimeter, remember the key word, perimeter was a distance, so we just measured, it was just like measuring from point A to point B. It was measurement units that were centimeters, inches, miles, kilometers, all those kinds of things. When we talked about area, we said that area was not a distance, it was a space. And we measured it not with straight lines, but we measured it with squares. And that's why we said that the units we used were square centimeters, or square inches, or square miles, or square kilometers. Volume cannot be measured in straight lines, cannot be measured with flat squares, because flat squares don't hold anything. Volume is measured in cubes. Think of an ice cube, think of a sugar cube. Cubes. Cubes are like shapes that whenever you look at one side, the side is a perfect square. So I've got a cube that I've drawn here. Let's imagine it's something like a sugar cube. The height of the sugar cube might be 1 centimeter. The length of the sugar cube would be 1 centimeter, and the width would be 1 centimeter. That's the definition of a cube. A cube has all sides equal. A square also has all sides equal, but a cube is a three-dimensional shape that doesn't just lie flat on the page, it comes out. If I was wearing 3D glasses, I would see it coming out to me. And because of that, it has room inside for me to put some stuff. Cubes have room inside them. A sugar cube, you can imagine it, has got all of its sides, but really the inside, it's full of frozen water. A sugar cube is a cube full of sugar that's been bonded together. So volume is measured in cubes. The cube that I've drawn here, with every side equal to 1 centimeter, we would say is a cubic centimeter. And notice there's now a 3 sitting up on the shoulder, because how many centimeters did I measure on this thing? Well, there is 1 for height, another centimeter for length, another centimeter for width. 3 different centimeter measurements giving me this 3 up here. How many centimeter measurements were on the area square? Well, there was a up and down and a left and right, 2 different measurements like this. That's why there's a 2 sitting on the shoulder of these guys. How many different centimeter measurements when I measured perimeter? Well, there was only 1. That's why there's no number. Actually, we could say there's an imaginary 1 sitting on the shoulders of these guys. And the fun thing is then, perimeter is really a one-dimensional idea. It's back and forth, not up and down and back and forth, just one direction, back and forth, or up and down, but not both. Look at the square. The square has got up and down and back and forth. It's got 2 different dimensions. That's why we call this a 2-dimensional measurement of area. But the volume, just like we said, is now a 3-dimensional measurement, because it's got an up and it's got a sideways, but it's also got a back dimension to it. 3 different dimensions. So volume is measured in 3-dimensional shapes that we call cubes. If every side of the cube is a centimeter, then I call that amount of volume that fits inside that cube 1 cubic centimeter. If the cube had all of its sides 1 inch, 1 inch, 1 inch, that would be a cubic inch. If all of its sides were a mile, and that would be a huge cube. This would be a cubic mile or a cubic kilometer. Cubic miles and cubic kilometers would be the kinds of things we would use to measure how much water in the ocean, because there is an awful lot of water that would fit inside a cubic meter. To give you another practical picture of where we might see this thing is in the springtime. I'm going to go to a new page. In the springtime, you might see people who get dropped off in their driveway one of these great big containers full of soil. And it might have a company name on the side, so-and-so sod, but inside is garden soil that they're going to put on their yard or something. Usually, this big bag that gets dropped off in their driveway is 1 yard tall, 1 yard wide, and 1 yard deep. There's our 3 dimensions again. Dimension 1, up and down. Dimension 2, left and right. Dimension 3, front and back. 3 dimensions. So the amount of soil that's in this bag is 1, because there's just 1 of them. Cubic, because it is the shape of a cube. It's not a square. That's measuring area. This is a cube. One side is a square, but the whole shape with room inside is a cube. And because every side is a yard, this is 1 cubic yard of soil. In other words, 1 cubic yard or 1 cubic yard of soil. There's a cubic yard right there. It's a cube, the size of a cube. It's how much soil fits inside the cube when every side of the cube is 1 yard by 1 yard by 1 yard. All right. So how do we calculate the volume of a shape? Well, for the purposes of this video, let's talk about a shape that's rectangular. So finding the volume of a rectangular container. All right, so I'm going to draw a rectangular container again. Now, all I've drawn so far is a flat rectangle. I could find the perimeter of that. What's the distance around the outside? I could find the area of that, how much space is on the inside, but we're talking volume, so we know that we can't just stop with a two-dimensional sheet. We need to make this into a three-dimensional container that'll actually hold something inside. All right, so there's a three-dimensional rectangular container, and it's got room for some stuff inside. We're going to calculate how much room. To do that, we need to know, well, how big is this container? What's the length and what's the width and what's the height? So let's say that the width of this container right here is let's use centimeters. Let's say the length of this container is also 3 centimeters. And let's say that the height of this container is, let's say, 6 centimeters. So when I'm asking what's the volume of this container, I'm really asking how many cubes are there inside this container? How many cubes? Now we could ask, well, what size of cubes are you talking about? Well, because my measurements are all centimeters here, I want to know how many cubic centimeters of space there are inside this shape. How many? So what I'm going to do is I'm going to start breaking this shape up into cubic centimeters. So I'm going to measure 1 centimeter up. There's my 6. 1, 2, 3, 4, 5, 6. There's my 6 measurements, 6 centimeter measurements. 1, 2, 3. There's my 3 centimeters measuring across the front, and there's my 3 centimeters measuring across the side. So I'm going to imagine that this container has got the bottom of it broken like this. So we've got the bottom layer of this container is divided up, and how many squares or how many cubes are on the bottom layer of this? Well, there were 3 cubes from across the width. 1, 2, 3 cubes that way. How many rows of 3 do we have? Well, we've got 1 row right there, 1 row of 3, 2, there's a second row of 3 cubes, here's a third row of 3 cubes, 3 rows of 3 cubes. I could go 3 plus 3 plus 3, or I could say, well, there's 9 cubes in that first layer. So 9 cubes in first layer. Well, how many layers am I going to have? Well, that first layer was 1 centimeter tall, 1 centimeter wide, 1 centimeter deep. My next layer is going to go the next centimeter up, and I'm going to count how many cubes are in that. Well, that next layer is going to sit on top of the bottom layer. It's going to have the same number of cubes in it. It's just going to sit on top. So there's a second layer of 9 cubes. The next layer, same thing. Another layer of 9 cubes. How many layers am I going to have? Well, it was 6 centimeters tall, so I'm going to have 6 layers of 9 cubes. So 6 layers of 9 cubes each. What's the total? The total equals, okay, so I know my 9 times tables. 9 times 6 is 54 cubes altogether. But what kind of cubes? Oh, well, these cubes were all 1 centimeter by 1 centimeter by 1 centimeter. So these are 54 cubic centimeters. So the volume of this container, is equal to 54 cubic centimeters. Cubic centimeter, again, picture a sugar cube. I could put 54 sugar cubes inside this container, 9 on the first layer, 9 on the next layer above it, 9 on the next layer above it, 6 different layers of 9, 54 sugar cubes, 54 cubic centimeters of room inside this shape. In other words, 54 cubic centimeters of capacity or something that I could fill up inside that shape. So, a common application of this might be, and now whatever I'm drawing, I have to draw it 3D, because we know that volume is the amount of room there is inside a shape. If I just draw a rectangular sheet of paper like this lying flat, there's no room inside it. There's space on it, that's area, but there's no room inside. So I'm going to imagine that we have a building. Here's a building, there's a door, and the building's rectangular, and heating and cooling company is going to install an air conditioner for this. To decide what size of air conditioner is going to be big enough to keep this thing cool in the summer when it's hot, they need to know how much air is there inside this building. Well, you and I both know the air doesn't just sit here. Air doesn't just sit along the bottom edges of the walls where we think about perimeter. That would be an example of perimeter. Perimeter is not how we measure air, because air isn't just around the outside of the shape. Air also doesn't just sit on one surface. Area is what we use to figure out how much space there is on one surface, but air just doesn't fit on a surface. Air fills the whole room. Air fills the whole thing. So what we need to do is figure out, when we're thinking about how much air there is in this room, we need to calculate the volume of this building. And we're going to get an answer that will give us a number of cubes. Because remember, volume is measured not in straight measurements like centimeters or inches. That's what perimeter is measured in, because it's a distance. It's not measured in squares. That's what area is measured in, because it's just talking about space on a surface. But here we're measuring in cubes. So if the length of this building on the front was, let's say, 30 feet, the depth of the building might be 20 feet, and let's say the height of it was 10 feet. You can see what I could do. I could take this wall and I could divide it up into 30 feet, and then divide this up into 20 feet, and I could start counting how many cubes would be in the bottom layer in this building. Cubes that are 1 foot by 1 foot by 1 foot. And the reason I'm talking feet is because notice all of my measurements here are in feet. So I'm trying to find out how many cubic feet are inside this building. Well, from the previous example, I know that if I times this number, I can find how many square or how many cubes in the bottom layer, and then times that by this number to find how many layers altogether. So we find out that the formula for volume is the length of something times the width of something. Now, if I stopped there, all I'm finding is area. This is the new thing. And remember that volume is three-dimensional? Look at how many dimensions I'm timesing. Dimension number 1, dimension number 2, dimension number 3. So in this case, the volume of this building would be 30 feet times 20 feet times 10 feet. Now, I'm just going to do this. 3 times 2 is 6. 30 times 20, there's a 0, I'm up to 600. I can times that by 10 now. So this is 6,000. And 6,000 what? Cubes, for sure. And how big are the cubes? Feet. 6,000 cubic feet of airspace, of space inside this building. If this building was filled up with water, 6,000 cubic feet of water. If it was filled up with air, which it will be, 6,000 cubic feet of air. So the company that's coming in to install the air conditioner would need to know the volume of this room is 6,000 cubic feet of air. So we've just mentioned what the formula is. The formula for volume, and just like perimeter and just like for area, it depends on the shape. So if I have some kind of a rectangular cube, which is what that building was, it was what the box was, a rectangular cube, every side is a rectangle, and we have a length, and we have a width, and we have a height. The formula for volume will always be length times width times height. Now, there's all sorts of other shapes. The shape that I started with was much more of a cylinder, like a coffee container. That's a whole different thing. The bottom of this is not a rectangle, it's a circle. So there's a whole different formula for that. The formula for this, just for interest's sake, is pi r squared h. But we could keep going. There's a different formula. There's a circle. That's just a line, flat thing. But what if I had something that was like a sphere, not just a flat circle on a page, but like a soccer ball or a exercise ball, and I wanted to calculate what was the volume of air inside that thing? There'd be another formula to calculate that, but it'd be quite different than these two because it doesn't have any straight sides at all. So every different shape is going to have a different formula to help us to calculate volume. Volume, again, the amount of room or capacity that we have inside a container.